The Lamborghini Miura was developed in the mid-1960s context, when Lamborghini was still a young company with no experience in mid-engine configurations for street cars. The Miura project began from a desire to experiment with a new technical layout, different from the front-engine GT models the company was producing. The Miura and Appo's development took place at Sant'Agata Bolognese, Italy. Unlike previous projects, the Miura did not start from a specific usage requirement, but from the idea of placing the engine in the car and Appo's center to improve weight distribution. At this stage, the mid-engine concept was more commonly associated with racing cars rather than street vehicles. Applying this layout to a road-going car meant Lamborghini had to reconsider how the chassis, body, and mechanical systems would coexist within a compact structure. The Miura chassis used a welded box-section steel frame structure, not a full space frame. This design created a simple, yet sufficiently rigid platform to test the mid-engine layout on a street car. The frame structure was designed thin and light to control overall weight. This made the chassis uncomplicated, but required precision in assembly to avoid deformation under load. The floor was integrated into the frame to form a unitary structure. This approach increased overall rigidity while keeping weight reasonable. Integrating the floor into the chassis also helped establish the seating position and the overall height of the vehicle, both of which were critical to achieving the Miura's low-slung proportions. The Miura body used thin metal panels shaped to cover the frame structure. The material was chosen to suit the requirements for soft and continuous body shaping. Body panels were formed with many curves, markedly different from contemporary front-engine sports cars. This design reflected the body being shaped to surround a novel engine layout. Panels were test-fitted and aligned directly on the frame. Alignment focused on continuity of curved surfaces rather than controlling gaps to daily use standards. This emphasis on surface continuity meant that visual flow took precedence over panel gap uniformity, a common compromise in early high-performance sports cars. The front end was designed low to reduce overall height and cover the front suspension system. This area did not serve as an engine bay, allowing low and extended body proportions. The rear covered the mid-engine bay. This design directly influenced cooling and heat exhaust arrangements. Because the engine occupied the central rear section of the car, airflow management and heat dissipation became integral considerations in shaping the rear bodywork. When the chassis and body were completed, the Miura had formed the basic structure of a mid-engine street car. At this point, spatial and structural limits were established for subsequent steps. This formed the foundation for Miura to move to the mechanical systems installation stage, where the engine and drivetrain would further define the car and Appo's driving characteristics. The Lamborghini Miura was equipped with a mid-engine, rear-wheel drive layout. This was a distinctive step compared to most street cars of the era, which used front-engine configurations. Lamborghini chose a 3.9-liter V12 engine for the Miura. The engine was mounted transversely, positioned right behind the cabin, to optimize overall length and weight distribution. Mounting the engine transversely allowed the wheelbase to remain compact while keeping the mass of the powertrain close to the vehicle's center of gravity. The engine block used aluminum alloy to control weight. This design allowed high power output while fitting the relatively light frame structure. The engine and gearbox were integrated into a single unit. This layout saved space, but placed high demands on heat control and lubrication. With the engine and transmission sharing a compact housing, thermal management became a critical factor, especially during extended high-speed operation. The intake system used carburetors, allowing mechanical adjustment of fuel delivery to the engine. Tuning depended heavily on operating conditions and maintenance. The mechanical ignition system was designed simply, suited to mid-1960s technical standards. Combustion stability depended directly on the precision of mechanical settings. As a result, consistent engine performance relied on careful calibration and regular mechanical attention rather than automated control systems. Power was transmitted to the rear axle via a differential integrated in the gearbox unit. This arrangement kept the front wheels focused entirely on steering duties. Independent suspension was equipped on all four wheels to control body motion and wheel geometry under high-speed conditions. Disc brakes were fitted on all four wheels, meeting deceleration requirements for a higher performance car than ordinary contemporary sports models. The unassisted mechanical steering system was retained, providing direct road feedback. Without power assistance, steering effort and feedback were closely linked to vehicle speed and road surface, reinforcing the direct mechanical nature of the driving experience. When all mechanical systems were completed, the Miura formed a new driving configuration for street cars, where the mid-engine played a central role in shaping driving feel. The Lamborghini Miura interior was designed in the context of it being one of the earliest mid-engine street cars. The cabin layout was directly influenced by the frame structure and the engine positioned right behind the driving compartment. Seating position was low relative to the road surface, suited to the body and oppo's overall height. The driver sat close to the front axle, creating direct reception of the car and oppo's movements during operation. Seats and contact surfaces in the cabin were designed simply, prioritizing body stability over extended comfort. Cabin space was limited by the low body and the engine bay close behind. Engine proximity also affected cabin temperature and noise levels, especially during sustained driving, further emphasizing the car's mechanical character. The instrument panel was laid out flat and wide horizontally. Analog gauges displaying revs, speed, and essential mechanical parameters were placed in direct line of sight. The steering wheel and gear lever connected directly to the mechanical steering and gearbox. Road and drivetrain feedback was transmitted straight to the driver without any softening intermediary. The Miura exterior was shaped with continuous and soft curves. The low and wide body clearly reflected the mid-engine configuration, different from traditional proportions of front-engine sport cars. The front end was designed low to complete overall proportions and cover the front suspension. The rear covered the engine bay while addressing heat exhaust needs for the mid-mounted engine. Exterior openings and vents were therefore not decorative elements, but functional responses to cooling and airflow requirements. When interior and exterior were completed, the Miura became a unified control space, where engine placement, body, and cabin combined into a whole suited to the era and oppo's street driving goals. After completing mechanical assembly and interior/exterior finishing, the Lamborghini Miura entered the final paint and inspection stage. This phase confirmed the car reached complete status before leaving the factory. The body was surface treated to remove minor imperfections arising during shaping and assembly. With panels featuring many continuous curves, surface treatment focused on uniformity and seamlessness of body surfaces. Finish paint was applied through a manually controlled process. Coverage and thickness were consistently maintained to protect the metal material and ensure surface durability in real-world conditions. After painting, body panels were rechecked for fit and straightness at joint points. This inspection ensured body curves maintained continuity under vibration and load. Because no post-delivery tuning was planned, all visual and structural corrections had to be completed before the vehicle left the factory. The engine system was started and run through a standard test cycle. Temperature, oil pressure, and rev stability were monitored to confirm the V12 operated as designed. The cooling system was tested under continuous operation. With a mid-engine, heat control played a critical role in maintaining vehicle stability. The drivetrain was evaluated through shifting and continuous power transmission. The integrated gearbox and differential had to operate consistently across different loads. The braking system was tested for deceleration, effectiveness, and stability. The brake configuration had to meet control requirements for a higher performance car than ordinary contemporary sports models. The suspension was checked for geometry and body motion control. The goal was to ensure basic stability within the established structural framework. The steering system was aligned for precision and direct feedback. All deviations were eliminated before confirming factory release standards. After completing inspection, the Miura was confirmed to meet release status. No additional tuning was performed after this point. After completing inspection, the Lamborghini Miura officially left the production line. From this point, the car no longer belonged to the internal technical process. The Miura was positioned as a high-performance street sports car, but with a technical configuration still very novel at the time. Using the car required adaptation from the driver. Drivers transitioning from front-engine vehicles had to adjust to different weight distribution and response characteristics. When beginning operation, all mechanical systems performed according to established characteristics. The mid-engine directly influenced acceleration and cornering response. The Miura did not use electronic assistance systems. The driving experience depended entirely on the driver and operator's feel and skill. At low speeds, the mid-engine layout and low body structure created clear differences for front-engine cars. The driver had to familiarize with visibility and reactions in urban conditions. At high speeds, weight distribution and suspension helped maintain stability according to mid-engine characteristics. Frame and road feedback was transmitted directly to the driver. These characteristics reflected design decisions made long before the car reached the road, rather than adjustments made during use. Delivery marked the transfer of responsibility from manufacturer to owner. From this point, operation and maintenance depended on real-world usage conditions. The Miura was not created to hide its technical features. Users had to accept that the driving experience directly reflected the car and oppo's configuration and structure. When Miura left the delivery point and merged into real traffic, the production process officially concluded.